Hi there, welcome to Z Online School. In this video we'll be completing the series about algebra. In this video we're going to be discussing two concepts in algebra: difference of two squares and quadratic expressions. The first few questions we're going to attempt are going to show how we can utilize the concept of difference of two squares in simplifying algebraic expressions. What we mean by difference of two squares is when we have an algebraic term that can be expressed as a square. When we talk about a square, we are talking about an algebraic term that can be written in form of a square. For example, this is a square. This is 2 squared, which is 4. What you need to understand is the relationship between the 4 and the 2. 4 is the square of 2, which means if we multiply 2 by itself, we're going to have 4. Similarly, when we have y squared is a square of y. These terms can actually even be combined. We can have 2 squared y squared, which will give us 4y squared. So the main concept that you need to always remember here is when we're utilizing the concept of the difference of two squares, you need to be able to find the square root of a certain algebraic term. Now, in the name we have the word difference. So when we can only apply this process on a particular question when simplifying if there's a minus sign in between two squares. For example, what we have here, we need to simplify y plus 1 divided by y squared minus 1. So the first thing we ask ourselves, since we have a negative in the denominator, is there any way in which we can work with that? There is a way that we can work it out, and that's the concept of the difference of two squares. So when you have two squares, this here is a square. Two things have been multiplied by itself, y and y. If you look critically, even the one here is a square. 1 multiplied by itself is still 1. So now, there's a principle that we need to always use. When we see a difference of two squares, for example, we have here y squared minus 1. This is the same as y plus 1 multiplied by y minus 1. If we expand this on our right hand side, we're going to have what is on the left hand side. We can do that quickly. So this is something you can always be sure of. When you are able to get two squares, one on the left of the negative sign, the other on the right of the negative sign, you can just get the term that is being squared. This y here is what was squared or multiplied by itself to get a y squared, and here 1 was being multiplied by itself to get a 1. Now, sometimes it won't be easy for you to do this very efficiently. So what you should do when you have a question like this is just find the square root. The best way to handle this question, as you have seen, we know how we can simplify this further. But what I will encourage you to do is, when you notice that there are two terms in an expression, the first term here is a square and the second one after the negative is a square, what you need to do is find the square root of this first term. So you say the square root of y squared, which is equal to y, and then you also do the square root of 1, which is 1. As long as you can find solutions for the square roots here, then you can continue. So since we have y and 1, we'll start with y plus 1 here, and then y minus 1. And like you can see, the y plus 1 here and the y plus 1 in the numerator are going to cancel out, giving us a final answer of 1 over y minus 1. This will be our final answer. Alternatively, if you like, you can also express this answer as y minus 1 to the power negative 1. Remember, we covered indices in part 2. This shouldn't give you a problem to be understood. The next question is also about the difference of two squares. We'll carry it out just the way we did the previous one. You notice in the numerator we have a difference of two things, but we can notice that if we say the square root of a, we're still going to have the square root of a. That can be simplified further. You get the square root of 12. 12 cannot be easily found. The square root of 12 cannot be easily found, so we'll still have that. So you notice we don't have squares in the numerator. Even though we have a difference, we don't have squares because we can't find the square roots of the variables that are being used here. We've got a, which is just a, it's not multiplied by anything. The 12 there is also not a perfect square. So the top part is going to remain a minus 12. However, in our denominator, we can see that if we find the square root of a squared, we're going to simply have a. If we find the square root of 144, if you know your multiplication tables, you should know this is 12. 12 multiplied by itself is 144. In an exam setup, you could just test a few numbers and you still get the same answer. So since we know what our square roots are, we have a plus 12 and a minus 12. Simplifying, you can see this a minus 12 is going to cancel with the a minus 12 at the top, and we're going to have 1 divided by a plus 12. This is our final answer. Again, here you would also write the answer as a plus 12 to the power negative 1. It doesn't matter so much. Anyone who's marking your work will be able to understand what that means. We have another question here. We're asked to simplify this. You notice we have squares in the numerator this time. In our denominator, we don't have anything that we can find the square root of. Additionally, there's a positive sign there, so it's an indication of doing nothing to that part. So watch out for those negative parts when you're applying the concept of difference of two squares. So first, we're going to try to find the square root of a squared x squared. You can see here we've got squares on both these, a and x. So our square root of that is going to be ax. In situations like this, when some people might get confused, just try multiplying your solution here by itself and see if you're going to get back to what was in the question. So here, if I say ax multiplied by, I'll show multiplication by that dot there. Because if I put another x, it might confuse us. You can see our final answer is going to be a squared x squared. So we found the correct square root. If you're not sure when you're working with variables, just do that simple check. The same thing will happen for the b squared y squared term. Our final answer is going to be by. We multiply by by itself, we're going to have b squared y squared. Now, since we know the square roots of what's in our numerator, we can continue with writing our solution. We write ax plus by, then multiplied by ax with a minus by. Always make sure when you write this, for the first few questions, before you get comfortable with expressing using the difference of two squares, test to make sure I have not made any mistake. You can notice we've got ax plus by both in the numerator and denominator, which we can cancel out and remain with ax minus by. So this here is our solution. This is very simple. Let's do another question. This is another question here. We're going to simplify this using the concept of difference of two squares. Now, if you directly try to find the square root of 3d squared, you notice 3 here does not have a square root. That means we need to perform some manipulations before we apply the concept of difference of two squares. Also, if you try to find the square root of 27, the same thing happens. We can't easily find the square root of 27. So we need to think of a way of manipulating this and then finding the difference of two squares. In such a question, the first thing you should do is try looking for a common factor in the first term, this 3d squared and 27. What number can go into both 3d squared and 27? Since we've done a bit of factorization at the start of the algebra series, I'm sure you know that from here we can factorize a 3, leaving us with d squared minus 9. If we expand this, we get back to 3d squared minus 27. We will now find the square root of d squared, which is d, and the square root of 9, which is 3. Next, we cancel what can be cancelled. The d plus 3 can cancel with the d plus 3 in the numerator. And hence, we are left with 3 multiplied by d minus 3, which we can simplify further to 3d minus 9 actually. So this is our final answer after we simplify. We have another question here which is interesting. This time around, we can find the square root of 9x squared and the square root of 1. So it's not a very difficult question. This will be 3x. If we multiply 3x by itself, we're going to have 9x squared. Whenever we have 1, always remember the square root of 1 is itself. Meaning, we're going to have this simplified to 3x plus 1, 3x minus 1 divided by 9x plus 3. Now, at this stage you might think we've done nothing. We can't cancel anything. But if you look carefully in this question, we can do more to the denominator. If we factor out 3 from the denominator, we'll be left with 3x plus 1. And hence we can now cancel this 3x plus 1 and that 3x plus 1, which leaves us with 3x minus 1 in the numerator and a 3 in the denominator. If you wish, you can simplify this further to x minus 1 over 3. There's no problem. I'm sure any teacher will be okay with you leaving the answer in that form too. We have yet another interesting question about difference of two squares. Here we've got to simplify 2x plus 14 divided by 2x squared minus 98. Right from the start, you can see we can't find the square root of 2, and we can't easily find the square root of 98. So the first thing we'll do, we'll factor out a 2. You can see even in the numerator we can factor out a 2, giving us 2x plus 7. In our denominator we also factor out a 2, leaving us with x squared minus 49. Now you notice the 2's here can cancel out, and our expression already looks a bit more simple. But if we check our denominator, we have a difference of 2 squares. Because we have a difference of 2 squares, we can simplify the denominator further by finding the square root of the squares that are involved. We can rewrite this difference of 2 squares as x plus 7 multiplied by x minus 7, where we can see that x plus 7 and this x plus 7 can cancel out and give us a final answer of 1 over x minus 7. Just like that, we have performed the concept of difference of two squares, which is actually a way of factorizing your answer. But here we're just looking at it as one of those procedures in algebra that is important. A key thing you should note about these questions that are involving the difference of two squares is that they will rely on some information that we've covered in part 1 and part 2 of algebra. Make sure you watch those parts so that you are able to see how everything builds up. Next, let's talk a bit more about quadratic expressions. So a quadratic expression is a special type of algebraic expression. We have linear expressions, the one that we've mostly encountered, where there's just a variable maybe and a number like this. This is an algebraic expression, a linear algebraic expression. So the difference in names are going to come from the power on the variable. If it doesn't have a power shown explicitly, for example here we know there's a 1 here but it hasn't been shown, this is known as a linear expression or a linear equation. When we have a square on one of the variables like this, usually we can say comfortably that this is a quadratic expression. If we have a 3, this can be referred to as a cubic expression or a cubic equation. Now, an important thing that you should always remember is that when we exceed these two, most of the times the resulting algebraic expressions will just be referred to as polynomials. But we can keep going with the special names. Cubic just means we have a 3 there. 4 also has a special name, but the most important thing you should remember are the first 3: linear, quadratic, and cubic. And then all those having a power of 4, power of 5, power of 6 can be generally referred to as polynomials. So our focus is on those expressions that have got a square on their variable. The most general form of a quadratic expression is going to be in this order. We have ax squared plus bx plus c. The a here represents a number which is a constant. The b represents a number. The c also represents a number. This is the full form of a quadratic expression. It will have a variable with x squared, a variable with x, and one without a variable. Even though we don't have this term in the middle, as long as we have the variable with a square, it's still a quadratic. Now, when we have quadratics, one important thing in algebra is being able to factorize them. For example, here in this question, we already have a quadratic, but it has been factored, or in other terms, it's written in its factored form. If we want the actual quadratic of this question here, in this part of the video that you've reached now, you'll be able to very soon move from this stage and reach to the factored form of a quadratic. When we have a quadratic that is in this form that I've just written here, that wasn't in the question, if we want to solve the quadratic given that it's equal to 0, the first thing is we need to take it into this factored form and then solve, like I'll show you very soon. Without factorizing, it's very difficult just by looking at the equation for you to find the value of x. So here we start just from the basic, where we already have a factored quadratic equation, and our job is just to solve it. The procedure to solve a quadratic expression that is factored is very simple. What you do is you get each of these factors, the first part here, 2x minus 5, you equate it to 0, and then you solve that simple equation, which means we're going to have 2x is equal to 5. When this negative 5 comes to the right hand side, it will be positive, and hence x is going to be 5 over 2. We also do the same for the other. X is equal to 3. So for this equation, there are two solutions. X is equal to 5 over 2, or x is equal to 3. Just noticed here, you forgot a negative. When this positive 3 goes to the right hand side, should become a negative 3. Just like I said earlier, this is a quadratic expression without being tempered. The question here tells us to factorize in preparation for us to solve quadratic equations that have not been factorized. There are many methods to solve quadratic equations. The easiest is factorization method for syllabus D most of the times, but other methods can also lead you to the answer. So that's the main method I'm going to be teaching you here. To factorize this quadratic, first of all, we need to understand some terminologies. The first is what we call a product, what we call a sum, and what we call factors. So a product is a special number that we get from a quadratic expression that has been given. How we get it is we multiply a and c. Remember I said the quadratic expression has got a form of a x squared plus b x plus c. A, b, and c are all numbers. In this question, a is equal to 2. I've just created some space so that we can write our expression and identify its parts. So this here is a, our b is here, and our c is this number here. To get the product, we multiply a and c. Our a is 2 and our c is negative 6. It's always important to not forget the signs. Why? If you can see here, we assume we have positive signs. So if we put a positive sign in between the x and the 6 here, we'll be having x plus negative 6. So the value for c is actually negative 6 and not a positive 6. Pay attention to that. It's a common source of error. So our product is negative 12. Next, we should see and look for our sum. Our sum is the b. And in this question, our sum is equal to negative 1. Then the trick here just comes to knowing what your factors are. So the rule is, the factors are two numbers that if you multiply, they equal to the product. Secondly, if you add them, they'll give you the sum. That's not very difficult. With some practice, you'll be able to handle this very quickly, but I'll show you the easiest way. To find the factors, what you need to do is start trying out numbers that can give you 12, starting from 1. 1 times 12 gives you 12, right? But if I add 1 and 12, I get 11. Now, as I'm testing out for addition and subtraction, as I'm testing out for the addition, I shouldn't forget the negative numbers also. For example, 1 multiplied by 12 gives me a positive 12. When looking for my factors, I should make sure even the sign for the product is taken care of. So in this case, I can say negative 1 multiplied by 12, which gives me negative 12. But the problem here is that if I add negative 1 and 12, I'm not getting my sum, which is negative 1. If I add this, you can see I'm having 11, which is not correct. So I'm going to change. Instead of starting from 1, this time I'll start with 2. I check 2 multiplied by what is going to give me 12. It's 2 multiplied by 6. But remember, we need a negative somewhere. This gives me negative 12. However, if I add this up, what do I get? I'm going to get 4. So this is not what I'm looking for. 2 and 6 are not going to work. Next, I go to 3. 3 multiplied by 4. I put a negative here. This gives me negative 12. Now, notice here, if I add negative 3 to 4, I have what number? I have 1. I'm very close, but my sign is wrong. So when this happens, just remember you've put the negative on the wrong number. So what we'll do is still use 3 and 4, but we're going to say negative 4 multiplied by 3, which is equal to negative 12 still. But when we say negative 4 plus 3, this time around, you notice we have a negative 1. So we have found two numbers that if we multiply give us negative 1, which is we have found two numbers, if we multiply them, negative 4 multiplied by 3 give us the product, which is negative 12. If we add these same two numbers, negative 4 plus 3, we have our sum, which is negative 1. So with that said and done, we can now go to the next step. Now, after we have done this successfully, we found our product, sum, and factors. The next thing is rewriting our earlier expression. This is now the solution. We have 2x squared minus x minus 6. I want to make a mistake on that. Now, where we have our sum, we're going to do some manipulation. Since these two numbers we have, negative 4 and 3, can give us negative 1, we are going to introduce them as they are here. Notice how I'll put them in, I'll add them, then this is going to be inserted here. And then we multiply by x. Then we subtract by our 6, which was already there. Notice what we have done is, where we had a negative 1, we've replaced the sum of our factors. This is a simple procedure, shouldn't get confused by it. Then after this, we are not going to simplify what we have here. Instead, we're going to expand it directly, write it like this. This step is very key. You are not supposed to simplify this, because if you simplify, you get back to the question where we started from. But always check that if you simplify, you get back to the question. Sometimes you might make a simple mistake and pick wrong factors. Now after here, we're going to do something we learned in the earlier parts of algebra, factorization by grouping. Here we have a square. We take two groups. This is our first group, and then this is our second group, and factorize them. From the first group here, I'm going to get my factors. 2x is a factor of 2x squared and 4x, can go into both. I'll be left with x here, I'll be left with negative 2. Then I go to the other group. From these two terms here, 3x and negative 6, you can see we've got a common 3. So I'll factor out a 3 and be left with x minus 2. Always when you do it right, what's in the brackets here is supposed to be the same. After that, your job is just writing what's in the brackets. We have x minus 2. Then what's left, if you cover the brackets, we are left with 2x plus 3. So we have completely factorized our algebraic expression, which is a quadratic expression. Notice algebraic expression, general, quadratic expression, a bit more specific. This is how that earlier question we solved can be factorized. Let's look at another question to perfect our skill of factorization. In this question, we're asked to solve. It's a hidden factorization problem. Most of the people will get confused from there. You see how this question will differ from other solutions that we will start having. So the first thing here is realizing this is a quadratic expression, and you can write it like this, or possibly this might confuse people. Let's just write it as it has been given. X squared minus 7x is equal to 8. So from here, what we'll have to do is get this 8 and bring it to the right hand side. Now I'm going to do it in a way that you don't usually see it. How I'm going to get rid of this 8 is by subtracting 8 from both sides, so that one thing can be made clear. I've subtracted 8 on both sides, meaning I haven't changed anything. Just like we performed some questions about indices, what we do on the left, we do on the right. We do the same here. I'm doing this to stress one thing, that after this 8 crosses to the left hand side, our equation is going to be equal to 0. If you forget this 0, then you can't solve this question. Most people just go and write the left hand side. It's not correct to do that, because you need that 0 to solve for this question. So after we have done this, next we will find the product, sum, and factors. This time I'll be abbreviating products with P. The products, we said, is the number on the squared term, which is our A, if you can remember, multiplied by the C. So our product is 1 multiplied by -8, which is going to be equal to -8. Our sum is going to be the number with the x variable, just the x, not x squared, which is -7. And then our factors are numbers that, if we multiply, will give us the product. If we add them, we'll get the sum. The easiest way is always start from 1. 1 times certain number to give you -8. 1 times -8 gives me -8. But if I add 1 and -8, do I have -7? Of course I do. So this one is very simple. 1 plus -8. You can see I'm adding here, but the result is kind of subtraction. If you say 1 minus 8, but yeah, you get the concept. So we have found the factors just by a simple approach. Always start from 1. Our factors are 1 and -8. So with this said and done, now we can continue solving this expression of ours. The first thing we should do is factorization, like you've seen us doing right now. This is leading us to the step where we said we have x squared, then we add the sum of these. I'm stressing to put the positive here just to ensure that everyone knows we are adding. So where we had the -7, replace with the sum of these two. This gives us x squared plus x minus 8x minus 8, which is equal to 0. Factorizing this is not a difficult thing. From the first group, we look at what's common in x squared and x. Of course, it's x, leaving us with an x for the x squared and a 1 for the x. If we expand this that we've just factored, we should get x squared plus x. You can check that. We go to the second group here. I put a minus sign there. You can see that 8 is common in both terms, so I'll put an 8 outside the brackets. Then x, remember the sign I put here should make me have a negative, so I put a positive like that. In most cases, just try to get what you had in the first brackets. If it was a positive or a negative, you do that. In this case it was a positive, so I'm pretty sure you'll be okay with knowing that it's a positive here. But again, test that the expansion of this will lead you back to the group that we were factorizing. Next, we write what's common, x plus 1 in the brackets like that, x minus 8, like this. After this, now this question is just like the one we started with, solving. To solve this, you remember we said the first factor here, or the first expression, is equated to 0, then you solve for x, which is supposed to be equal to -1. You do the same for the other expression. X minus 8 is equal to 0. X is going to be equal to 8. So we have got two solutions. X is equal to -1 or x is equal to 8. Both of these should be correct solutions if you plug them into the earlier algebraic expression that we are solving. Here we have some interesting question about factorizing completely. You might not see why it's interesting. Let's get working it out. So if we want to factorize this, the first thing we do is look for what's common in the first algebraic term and the second algebraic term. 3 can go into itself and 3 can go into 12. So we know that 3 is a factor. X can go into itself on the 12xy squared term, and it can also go into x to the power 3. So we'll have a 3x outside the brackets, leaving us with x squared, and here it will leave us with -4y squared. Most people will end here, forgetting that in this video we talked about the difference of two squares. So factorizing this completely will mean we need to treat these difference of two squares and simplify them further. So these are just questions to ensure you see how difference of two squares can also be applied. Remember, we said you need to find the square root of the squares that are involved in the difference. X squared, the square root of x squared is x. The square root of 4y squared is 2y. So our solution is x plus 2y, x minus 2y. Some people will start with the expression with negative. It doesn't matter, both of them are correct. Here we have an additional question. This is a quadratic expression and we are required to solve it. You notice we don't have a c term, we don't have a constant. Usually we are supposed to have ax squared plus bx plus c. We don't have this. So how do we treat this question? How do we solve it? If you try using solving by factorization, you notice your product is going to be 0 because you don't have a c. Your sum, yes, you'll be able to have it. It's going to be -2. But then you have to look for factors. Remember, the factors are two numbers that if you multiply by, you get the product. If you add them, you get the sum. So it's not really going to work out if you go by factorization method. So what you do here is we use a different kind of factorization. We don't find the product, sum and factors. Instead, we just say the left hand side can be factored in this form, x minus 2, like that. And then we can confidently say x is equal to 0 or x is equal to x minus 2 is going to be equal to 0. If you try out both x, if you put x to be 0, you have the answer 0. If you put x to be 2, you also have 0. Remember, whenever you solve an equation, that solution can be tested. So our two solutions are that x is equal to 0 or x is equal to 2. 2 squared is 4. 4 minus 2 times 2 is 0. You can see everything adds up. Here we have another similar question. It's just to cement what we've talked about. We have a 4, we have an 8. 4 can go into 8, so we can factor out a 4 and a y, leaving us with y minus 2, which is equal to 0. So we equate 4y to 0, divide both sides by 4. 0 divided by 4 is possible, so y is equal to 0. And then we also equate y minus 2 to 0. So this is similar to what we were doing to those quadratic expressions that were already in their factored form. Our solution is going to be 2. So y is equal to 0 or y is equal to 2. These answers are just coincidental. The solutions for such questions are not always going to be 0 and 2. Please don't master that answer. It's just a coincidence that even in this question we have 0 and 2 as our answer. That's it about the basic algebra that you find in your past paper questions, both in paper 1 and paper 2. If you watch all 3 parts, I can guarantee you syllabus D won't be a problem for you in the exam. Make sure, if you haven't watched part 1 and part 2, you watch them so that you get prepared well. If there are any questions that you have, be free to ask your questions in the comment section. And if you'd like to see specific videos, you can write down in the comment section also.